Hello, welcome friends. Me Anila. The topic of my discussion is about detection of compound by electronic configuration and molecular weight. But before this, don't forget to like and subscribe my channel and press bell icon. Before coming to the main topic, I would like to tell you something about electronic configuration. What is electronic configuration? So, in a neutral atom, the proton, electron and neutron are subatomic particles of atom. Proton is positive charge, electron is negative charge and neutron is neutral in charge. Proton and neutron lies in the center called nucleus. Electron with negative charge and very low mass revolve around the nucleus. So these electrons revolve around different orbits and shells. This is called as electronic configuration. For every element, there is different electronic configuration. In this video, we will detect compound by electronic configuration and molecular weight. Example number 1. An unknown compound contains three elements with electronic configuration. First element 1s2, 2s2, 2p2. Second element 1s1. Third element 1s2, 2s2, 2p4. Molecular weight of compound is 180 gram per mole and mole ratio between atoms is 1 is to 2 is to 1. Identify the compound. So in the example 1, the unknown compound, we have to identify the compound. Three elements with their electronic configuration of neutral atom is given. First element has neutral 1s2, 2s2, 2p2. S orbital is spherical in shape, p orbital is dumbbell in shape, d orbital is clover leaf shape and f orbital is complex in shape. S orbital can occupy maximum 2 electrons. P orbital consists of 3 orbitals, each containing 2 electrons, so total of 6 electrons. So we have electronic configuration is given, molecular weight is given, mole ratio between atoms is given. We have to identify the compound. Solution. First element has electronic configuration 1s2, 2s2, 2p2. If we add the number of electrons 2 plus 2 plus 2, 6. There are 6 electrons in the neutral atom, so it is carbon because carbon atomic number is 6. Second element is 1s1, it is hydrogen because only one electron is present, so it is hydrogen. Third element is 1s2, 2s2, 2p4. If we add 2 plus 2 plus 4 is equal to 8. So the 8 is the atomic number of oxygen. So in a neutral atom it is oxygen. So we have identified elements by electronic configuration. S orbital is spherical in shape and p orbital is dumbbell in shape. So carbon is to hydrogen is to oxygen, 1 is to 2 is to 1. The mole ratio is already given in the example. So the empirical formula is CH2O. Now we will calculate empirical formula weight. 1 is the number of carbon atom, 12 is the atomic weight of carbon, plus 2 is the number of hydrogen atom into 1 is the atomic weight of hydrogen, plus 1 is the number of oxygen atom into 16 is the atomic weight of oxygen. So empirical formula weight is calculated to be 30 gram per mole. Identified elements and empirical formula weight. We will calculate now value of N is equal to molecular weight divided by empirical formula weight. Molecular weight is already given in the example. 180 gram per mole divided by 30 gram per mole, N value becomes 6. Now we can calculate molecular formula by a formula. Molecular formula is equal to N into empirical formula. The value of N is 6 into empirical formula CH2O. Multiply this by 6, we get C6H12O6. So the molecular formula of compound is calculated to be C6H12O6. So the compound is glucose or fructose. Because both have the same molecular formula but different structural formula. Glucose contains aldehyde group while fructose contains ketonic group. Empirical formula is the simplest formula and molecular formula is the actual formula. So we have detected the compound. Example number 2. An unknown compound contains 4 elements with electronic configuration. First element 1s2, 2s2, 2p2. Second element 1s1. Third element 1s2, 2s2, 2p3. Fourth element 1s2, 2s2, 2p4. Molecular weight of compound is 194 gram per mole and mole ratio between atoms is 4 is to 5 is to 2 is to 1. Identify it, the compound. So this, as already discussed in example 1, here we have unknown compound. It contains 4 elements and the neutral atom. First element, second element, third element, fourth and electronic configurations are given. Molecular weight is given. Mole ratio between atoms are given. We have to identify the compound same as the previous example. Solution. First element is 1s2, 2s2, 2p2. It is carbon. Why? Because 2 plus 2 plus 2 becomes 6. 6 is the atomic number of carbon. In neutral atom, number of proton is equal to number of electron. So it is carbon. Second element 1s1, it is hydrogen because it has 1 electron. Third element 1s2, 2s2, 2p3, it is nitrogen because when we add 2 plus 2 plus 3 it becomes 7. 7 is the atomic number of nitrogen. Fourth element is 1s2, 2s2, 2p4, it is oxygen because if we add 2 plus 2 plus 4 it becomes 8. 8 is the atomic number of oxygen. So we have detected the elements carbon, hydrogen, nitrogen and oxygen. Now the mole ratio between atoms are given. Carbon is to hydrogen is to nitrogen is to oxygen. 4 is to 5 is to 2 is to 1. So C4H5 and 2O1 is the empirical formula for the unknown compound. We will calculate empirical formula weight. 4 is the number of carbon atom into 12 is the atomic weight of carbon plus 5 is the number of hydrogen atom and 1 is the atomic weight of hydrogen plus 2 is the number of nitrogen atom into 14 is the atomic weight of nitrogen plus 1 is the number of oxygen atom into 16 is the atomic weight of oxygen. After calculating, empirical formula weight is calculated to be 97 gram per mole. Now we will calculate value of N is equal to molecular weight divided by empirical formula weight 194 gram per mole as already discussed in the example divided by empirical formula weight 97 gram per mole. The value of N is calculated to be 2. Now we have to calculate molecular formula is equal to N into empirical formula. Empirical formula is the simplest ratio between atoms while molecular formula is the actual formula. We will put the value of N2 into C4H5 and 2O. We will multiply empirical formula with 2. We get C8H10 and 4O2. So the molecular formula is calculated. So this is the molecular formula of caffeine. So the compound is caffeine. In this way, by electronic configuration, by molecular weight, and the ratio between atoms are given, we can detect the compound. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.